So in the previous lecture, we have discussed about the solution of this hypergeometric equation about the point x is equal to 0 and x is equal to 1. In this lecture, we are going to discuss a solution of this hypergeometric equation about the point x is equal to infinity. That means we need to solve this differential equation for a larger value of x, not in the neighborhood of 0, but it is beyond that. So for that, let us consider x is equal to 1 upon t. That means t will be 1 upon x. Now what we will do, we'll convert this differential equation into this x is equal to 1 upon t. So when we will have x is infinitive, then your t will be 0. Because x is infinitive, so t will be 0. So we will convert this differential equation into such differential equation which has a regular singular point at 0. So we need to convert this differential equation into this new variable. So what will be the y dash? As per the definition, that is dy by dx. And by chain rule, we can say it is dy by dt into dt by dx. So by taking this derivative of t with respect to x, will gives you, this will gives you dt by dx is minus 1 upon x square. But 1 upon x square is in terms of t, we can write down this is minus 1 upon t, sorry, minus t square, because 1 upon x is t. So 1 upon x square is t square. So it is minus t square. So dy by dt into minus t square is there. So finally we'll have minus t square into dy by dt. Y double dash will gives you d square y by dx square. So as per this, this is d by dx of dy by dx, but dy by dx we have calculated that in terms of t. So this is d by dt or dx of minus t square into dy by dt. So here I can use the chain rule. So that is d by dt of minus t square into dy by dt into dt by dx. Here we can apply the product rule. So that will gives you y double dash is equal to, and I'm taking that minus sign out. This minus sign is out, and derivative of t square into dy by dt by applying the product rule is square as it is, and the derivative of dy by dx is d square y by dt square plus derivative of t square will be 2t and dy by dt as it is into minus t square is there because that is dt by dx. Dt by dx we have calculated, it is minus t square. So we have this. So if you multiply this t square inside and this minus minus become plus, so finally you will have t power 4 d square y by d t square plus 2t cube dy by dt. Now if we substitute this all value, that is y double dash, y dash, and this x is equal to 1 upon t into this equation 1, if I call it, this is equation 1. So substituting to equation 1, we get 1 by t, because this is x, which is 1 by t, 1 minus 1 by t, y double dash, but y double dash, the value of y double dash is this, which we have calculated, that is t power 4 d square y by dt square plus 2t cube dy by dt plus inside c minus a plus b plus 1 into x is 1 upon t. Then y dash we have calculated, it is minus t square into dy by dt. So this is minus t square into dy by dt plus the value of y, that is minus aby equal to 0. So this is the things we got. If we take the LCM here, then what do we get? This is t power 4, and if I take LCM here, or I can just multiply these two brackets and multiply with, so that means I need to calculate what would be the coefficient of d square y by dt square. This is t power 4, and if you take LCM, that denominator will have t square. So only t square left, and inside bracket t minus 1, d square y by dt square is there. This is the coefficient of d square y by dt square. Now what is the coefficient of dy by dt? Let us see that. Because this quantity is multiplied to t cube. So in the denominator we have t square. So it is actually get t into 1 minus t, and this 2 is already there. And here we'll have whole this quantity into t square, and but it is of minus sign. So it is minus t square into c minus a plus b plus 1. If I take the LCM at 1 upon t, so it is ct into 1 upon t square. And this t square is multiplied, so that's why it is t square is not t square, but it is t upon t. dy by dt. So there are two terms of dy by dt is there. The first term is there when this t cube is multiplied to this quantity, but that will simplify as this. And when this t square is multiplied to this quantity, and if I take the LCM, that is ct minus a plus b plus 1 into t square. Now if we can see that this t is cancel out, and 1 t you can take out from, and this out from this bracket, and this minus AB y as it is. So that will include all the terms. So finally what we get, that is t square into 1 t minus 1 d square y by dt square. Can take t common from that quantity. T is here also, here also. And so it is 2 into, so what we have here, let's see that, that is 2 into 1 minus t, after commoning out that t from this. So this t and this t will common out. So it is 2 into 1 minus t minus ct minus minus plus, this minus minus become plus a plus b plus 1. So that is a coefficient of t here. It is 2 minus c. So what we have, and the constant term will be, you can just see that 2 so it will be t minus 1. So no, not t, 1 minus t, it is t minus 1, not 1 minus t, this is t minus 1. So this is 2 into t minus 2 minus ct plus a plus b plus 1. Should I do this calculation again? See, here what we have, these are the coefficient of t d square y by dt square. That is clear because you multiply this one. Now the coefficient of this dy by dt. The first one is, when you multiply this is t minus 1, and this t cube is multiplied and be divided by t square, so it is t, and this 2 is already there, and this plus, due to this it will become minus, and if you take LCM, this is ct into a plus b plus 1 into t square. This 1t is cancelled with this one because you take the denominator. Now if you multiply this will be 2t square minus 2t minus, and 1t I am taking common, so that's why this 2t is not come. So if I take this 1t common from here and here, so there is no t, and then we simplify, then it is 2t minus 2 minus this ct, minus minus become plus, a plus b plus 1. So the coefficient of t here, it is 2 minus c, that we have here, 2 minus c into t, and a plus b plus 1. Plus 1 or minus 1, due to minus 2 plus 1, so it is minus 1. This is the coefficient of dy by dt, minus aby is as it is. So now if you divide this equation by this quantity, then this differential equation can be written as d square y by dt square plus, if you divide this, 1t is cancelled out, so we will have a plus b minus 1 plus 2 minus c into t upon t into t minus 1 dy by dt minus ab upon t into t square into t minus 1 y equal to 0. So if you compare this equation with our standard equation, that is d square y by dx square plus p of x into dy by dx plus q of x into y equal to 0. So you will have p of x. So here you will have p of x is a plus b minus 1 plus 2 minus c into t upon t into t minus 1, and q of x is minus ab upon t square into t minus 1. Now we should note that this p of x and q of x are not analytic at the point t equal to 0 as well as t equal to 1.
सर ct स्क्वेर नहीं આવે
ct square કઈ જગ્યાએ
જે ફર્સ્ટ ઇક્વેશન છે ને એમાં મતલબ ફર્સ્ટ ઇક્વેશન છે ને એમાં 2 માઇનસ ct નહીં ct સ્ક્વેર વધશે
અહીંયા see, this t is already there. I have taken out t from here. This yellow color line, you see this yellow color line? The t is common out. 1 t is common out. So this whole quantity multiply with t. So that's why it is, yeah, you are saying if you are multiplying this t inside, then it is ct square, 2t square. Please check your calculation. So that's why here it is outside t, and that t, when you multiply t square upon t minus 1 divided by t square into t minus 1, so 1 t is cancelled out due to this t square. So that's why it is only t. Now one can note that this p of x and q of x are not analytic at the point t equal to 0 and 1. So we can write, we note that p of t and q of t are not analytic at equal to 0. Therefore, t equal to 0 is the singular point. And t into p of t, if you can see, that is a plus b minus 1 plus 2 minus c into t upon t minus 1. So if you can see the previously, this t into p of t, where t is cancelled out. Hence we have this. If you can write down into the series form, then we can write this as a plus b minus 1 upon t minus 1 plus 2 into c into t. Or I can just simplify as 1 over 1 minus t. We know that it is 1 plus t square up to so on. This is t minus 1 t plus t minus 1 plus 2 minus c into 1 plus t square up to so on. So what will be the constant term here? P0. P0 is the constant term into this series that we know. So when this a plus b minus 1, when it multiply to 1, that will be the constant term, and it is having the minus sign. So it is minus of a plus b minus 1 is the constant term. So it is 1 minus a minus b is your P0. Next, what will be the t square into q of t? So we know that it is t square is, qt is this minus ab upon t square into 1 minus t. So it is t square into minus ab upon t square into 1 minus t. So t square will get cancelled. So it is minus ab. And 1 minus t, we know that it is write down as it was t minus 1. 1 minus t is this. So that's why again you have to multiply this minus sign. So this minus minus become plus, and the series will get 1 plus t square up to so on. So here you will have q0, which is AB. So therefore, what we can say, this t into p of t and t square into q of t are analytic at x is equal to 0, because they have the power series. Therefore, x is equal to 0, sorry, not x is equal to 0, t equal to 0 is the regular singular point of ODE of this differential equation. What is that equation? Which equation? That is this equation. This is the equation number 2, if I call this one. So this is the t is a regular singular point of the equation 2. So hence what we can say, what is the value of x is 1 upon t. So hence x is equal to infinitive is the regular singular point of ODE 1, because the ODE 1, this second equation is come from the first equation by replacing x is equal to 1 upon t. So hence this t equal to 0 is the regular singular point of this ODE2. That means x is equal to infinity will be the regular singular point of the hypergeometric equation 1. So that means we need to solve this equation and we need to get what is the solution for that about the x is equal to infinity. So for that I need to write down what is the identical equation. So consider the identical equation. That is m into m minus 1 plus m into p0 plus q0. As you know, the identical equation can be written in this form, which implies m into m minus 1 plus m into p0 that we have calculated is a minus 1 minus a minus b, and q0 is ab that we have concluded from the previous discussion. That is p0 is this and q0 is ab. So that's why we have this. So hence this is m square minus m plus m into 1 minus a minus b plus ab. And you just observe that this minus m, and when you multiply this m to this one, it will be plus m. So it will get cancelled. So it is m square minus a plus b into m plus ab equal to 0. This is the things we got by simplifying this. Due to this minus sign is out also out. And this is m square minus am minus bm plus ab. You see that from this to m is common out, so it is m into m minus a, and from this b is common out, so it is m minus a, b into m minus a. So hence this is gives you m minus a into m minus b equal to 0. So this will implies m equal to a b. So that means the solution of this hypergeometric equation is a and b. They are the 2 points of this hypergeometric equation. Thus, what we can say, m equal to a and m equal to b are the exponent of Frobenius series solution. Okay, that means what this means, that what we have the Frobenius series solution x raised to a and x raised to n plus m. So this value of m is a and b. They are the exponents of this Frobenius series solution. So the one way is to solve this equation now by taking y equal to this one, and in the as we are doing in the Frobenius method. So instead of doing that, so in place of applying Frobenius method, we convert again this equation 2 into Gauss hypergeometric equation by substituting y equal to t power q w. So instead of applying the Frobenius method to write down or to get our calculation shorter, we further convert our Gauss this equation 2 into the Gauss hypergeometric equation by substituting y equal to t power q w, where w is a variable or a function. Okay, so it is a form it is a function of, I can say it is a function of t or so. So what is dy by dt? As per the rule, product rule, this is t power q dw by dt plus q into t power q minus 1 w. What is d square y by dt square? That is d by dt of dy by dt. That is d by dt of this whole thing. That is t power q dw by dt plus q into t power q minus 1 w. So you have to apply the, first of all, additional root for this derivative and then product rule for derivative. So using that, we can say that d square y by dt square will be a into t power. You can see that if I write down here, it is actually not a, but it is the derivative of this quantity. That is, so we can write down q t power q minus 1 dw by dt plus t power q d square w by dt square. Then we can have this quantity, that is q into q minus 1 into t power q minus 2 w, then q in plus q into t power q minus 1 as it is. Derivative of w is dw by dt. Now, sorry. So t w will have, that is t power q d square by dw dt square. That is the coefficient of this. The dw by dt will have the two places. So we can have, that is, and we can just see that both these things are same. So that's why it is 2 into q t power tw t power q minus 1 into dw upon dt. This will be a same term, that is q into q minus 1 t power q minus 2w. I just replace here d square y by dt square by w double dash, and dw upon dt is d dash and q equal to a. Then we will have dy by dt. Dy by dt is this, so that is t power a w dash plus a into t power a minus 1 w. This is the first thing we got. And the d square y by dt square, from this it is t power a dw double dash plus 2 into a t power a minus 1 w dash plus a into a minus 1 t power a minus 2w. Now substituting this value of dy by dt, the square y by dt, and y equal to t power aw into the equation 2. So let me write down first what is the equation 2. So the equation 2 is this. So instead of writing this equation, I just write down this equation, that is the same. So let me write that first equation. So we'll have t square into t minus 1 into y double dash. Y double dash is this whole thing. So let us write that. So that is t power a w double dash plus 2 times a t power a minus 1 w dash plus a into a minus 1 t power a minus 2w plus the quantity that we have, it is 2 minus ct plus a plus b minus 1 into t into y dash or dy by dt. The dy by dt is t power a w dash, that is from this t power a w dash plus a into t power a minus 1 w minus ab, the value of y, that is t power a w equal to 0. Further, you just simplify this quantity. That means you have to write down what are the powers of, or what are the coefficient of w double dash, w dash and w. Let us write down that here. So you just see that what is w double dash. So w double dash, the coefficient of w double dash is t power t square into t minus 1 t power a. So that is t into t minus 1 t power a plus 1 w double dash. So I just, instead of writing t square, we'll just write down t into t minus 1 t power a plus 1. This is the first coefficient we got. Plus, what are the coefficient of w dash? So w dash is coming at here as well as here. Let me write down the w dash here now. So we have w dash is t square. So this t square is together with t power a minus 1. So it is t power a plus 1. So we have 2a into t power a plus 1 into t minus 1. That is the coefficient of w dash. Plus this a power t here is there. Sorry, t power a is there and this t is there. So it will become t power a plus 1. And this quantity is as it is. Inside bracket 2 minus c t plus a plus b minus 1 into w dash. Now the last term is of w. So w is at the three places. So this t square is multiplied to this here a power, so t power a minus 2. So this t square, so this t power a. So finally what we have, it is t power a into a minus 1 into t minus 1. So this is the coefficient we have. Plus this whole quantity is multiplied to this. So that's why this t is multiplied to this quantity t power a minus 1, that is t power a. So it is a into t power a into this quantity is as it is. That is 2 minus c t plus a plus b minus 1. And then lastly we have minus ab t power a and whole into w equal to 0. Further, you can observe that in this t power a plus 1 is common out, in this t power a is common out. So further, we can simplify or we can write down this equation as t into t minus 1 t power a plus 1 w double dash plus t power a plus 1 inside bracket will have 2a into t minus 1 plus 2 minus ct plus a plus b minus 1 w dash plus t power a is common from these three terms. What we will get here, it is a into a minus 1 t minus 1 plus a into 2 minus c t plus a plus b minus 1 minus ab into w equal to 0. See, also you can observe that this a is also common from these three terms. So that also I can take out. Okay, this a is also common. So that is also we can take out here. So this is a minus 1 into t minus 1 plus this minus b. Further, I can simplify this quantity and also this quantity. I can write down what are the coefficients of t for separately, what are the constant terms separately. So that we can write down into the next slide. So finally, what we got is t into t minus 1 t power a plus 1 t into t minus 1 t power a plus 1 w double dash and t power a is there, t power a plus 1. Inside bracket, you just observe that the coefficient of t are 2a and 2 minus c. So both together we can write down it is 2a minus 2 minus c. So plus 2 minus c into t plus this 2a together with, so it is minus 2a together with this a, so it is minus 2a together with this a, so it will become minus a plus b minus 1. So it is minus a plus b minus 1 into w dash plus a into t power a. You can also further simplify this. This is a, there are terms of t here and here also. So it is a minus 1 plus 2 minus c. Let be as it is. Let it be as it is. So it is a minus 1, t minus 1 plus 2 minus c t plus a plus b minus 1 minus b w equal to 0. Actually, further, I just see that the coefficient of w, I can simplify further, and let us see what will be that. So the coefficient of w is this: a into t power a. Inside bracket we have whole this thing. See what I can write down. This is a minus 1. Okay, so this is a minus 1 is here also. So I just take out a minus 1 is common from this terms. This one and this. So a minus 1 is common. So what is left inside, that is t minus 1 plus 1. This 2 minus c into t as it is minus b will be get cancelled. So you have this. This 1 is get cancelled. So this is a into t power a into a minus 1 into t plus 2 minus c into t, and t get common. So it is a t power a plus 1. Inside bracket it is a minus 1 plus 2 minus c. So we'll have a t power a plus 1, that is a minus c plus 1. So whole this quantity is now converted into this one. So finally what we get is t into t minus 1 t power a plus 1 w dash plus whole this quantity, which having the constant is this and the coefficient of t is this. Sorry. So it is t power a plus 1. Inside bracket we'll have 2a plus 2 minus c into t minus a plus b minus 1 into w dash plus the coefficient is this now changed to. So it is a into t power a plus 1 inside bracket a minus c plus 1 into w equal to 0. So you just observe that this t power a plus 1 is common from all these three terms. So that get cancelled. And so this will gives you t into t minus 1 w double s plus 2a minus 2 minus, sorry, plus 2 minus t minus a plus b minus 1 w des plus a into a minus c plus 1 w equal to 0. If I multiply this equation by minus sign, so this is t into 1 minus t w dash, w double dash. I'm multiplying minus. So this t minus 1 now become 1 minus t. This will become plus. All this term will become minus. So there is a minus b plus 1. I'm writing this is as first one. Then it will be minus this term, that is 2a plus 2 minus c t into w dash minus a into a minus c plus 1 w equal to 0. This equation we got. Can we write down this is as the terms of hypergeometric equation? So in the hypergeometric equation, the last term is a into b, if you can remember. And this is nothing but the c minus a plus b plus 1. So I want to write down this term into that form. So that's why we can write down this is as t into 1 minus t w double dash plus this quantity as it is, that is a minus b plus 1 as it is. Now instead of b we have a minus c plus 1. So according to that we will have it is a plus a minus c plus 1 plus 1. So you just observe that this is a and this is your b plus 1 w dash. That is exactly the same thing. Into t is there. I forgot that t into t. Into t w dash minus a minus c plus 1 w equal to 0. And this is, you can observe that this will be the nothing but the hypergeometric equation. And in place of a we have a, in place of b we have a minus c plus 1, and in place of c it is a minus b plus 1. So we can say that it is in the Gauss hypergeometric equation form where a, b, c are replaced by a comma a minus c plus 1 and a minus b plus 1, that you can observe from this. So then its solution at regular singular point p equal to 0 is y equal to c1 f of abc x plus c2 x raised to 1 minus c f of a minus c plus 1 b minus c plus 1 2 minus c 1 minus x. This is the solution if abc is the that quantity. But here the quantity, instead of a we have a minus c plus 1, instead of b we have this. So therefore the solution, that is the w, we can write down is c1 f of a, instead of a we have a, instead of b we have a minus c plus 1, a minus b plus 1 x, instead of x we have actually t, so that is your t, plus c2 t power. Now what is 1 minus c? C is this, so that will gives me a minus b, sorry, b minus a. f of a minus c plus 1. This is a minus c. So a will get cancelled, and plus 1 minus 1. So it will become b. Then b minus c plus 1. b is this minus c. So this minus this, a will get cancelled, b will become plus, and 1 will get cancelled. So it is, we get b minus c plus 1. Then 2 minus c, 2 minus this, which will gives you b minus a plus 1, and instead of 1 minus x, we have 1 minus p. So this is a solution of w. Now I want actually y. Y, the value of y is t power a into w. So the w is t power a minus t power minus a into w. Sorry, into y. That is 1 upon t power a into y. And what is 1 upon t power a? It is actually x power a into y, because we have assumed that x is equal to 1 upon t. So finally, the solution will be w equal to, by replacing this x power a into y into this equation. So finally, the solution is x power ay equal to, that is this c1 f of a into a minus c plus 1, a minus b plus 1. Instead of t, we have 1 upon t, sorry, 1 upon x. So it is 1 upon x plus c2. It is t power b minus a. So here it is 1 upon t. So it is a minus b. So it is x power a minus b f of b into b, sorry, b comma b minus c plus 1, b minus a plus 1, 1 minus 1 upon x. This is the solution of the equation at regular singular point at infinity, x is equal to infinity, which is the solution of the hypergeometric equation at the point infinity. So this completes the solution for this differential equation.